Hello, Math 1050. This video is going to be for section 1.6, but I want to do a couple little housekeeping things before we get to the lesson. First of all, I want to show you how to find due dates in ALEKS. So I'm going to bring up my student screen. So this should be the same as the screen you see. So when you first log in, it probably looks like this on the Pi. So of course, Start My Path can get you into the topics that you need. You can always view the assignment list right there by clicking on that, and that will show you what your current assignment is that you're working on. So you can see that this student account has only one of the 7 topics in 1.1 done and still has all of 1.2 and 1.3. So it'll show you how far you are on the week's assignments. You can view upcoming here, and it will add the next few assignments. So next week, on the 5th of September, we'll have 1.4, 1.5, 1.6, and 1.7 due. And then there is a practice test coming up. It is opening. I was able to talk to the college, so they are opening it on Thursday the 26th. So you'll see there that that's available Thursday and still closes on Sunday at midnight. And I'll talk more about the practice test in just a second. So another screen or another place that is good to look for your due dates, I think, is the timeline right here. It will show you what's going to be due next. You can zoom out a little to see more weeks, and it has the practice test down there at the bottom with the window in green. So this is showing what I have due. Right here, I have 1 topic done and 15 topics left, and it's showing me that. So you can use that screen if that's helpful. If you're having problems navigating, you can email me or ask other students, and they can help you as well. All right, so this Sunday, sections 1.1, 1.2, and 1.3 are due. And then the practice test will open Thursday, August 26th, and close on Sunday, August 29th. The testing center's website is down here, testing.dixie.edu. So you can use their website to get their hours, if there's any dates that they might be closed coming up for holidays or anything. And I believe they also have a map to where they're at. They're kind of like across from Swig, that's just south of the boulevard. When you go to take a test at the testing center the first time, it's kind of intimidating. You do need to make sure you have your photo ID, and you need to take your calculator, and you also need to have your D number and your login information. What they'll do is, they'll check who you are, and they will take you to a computer. They will have you log in to your Canvas and to your ALEKS on that computer, and then you'll go to that screen I showed you a second ago. Let me see if I can go to it. You'll go to that assignment screen, and you'll actually click on the test. Now, it's not open right now, so I can't click on it, but when you click on it, it will pop up a screen for the password, or a pop-up for the password, and the testing center employee will type in that password. So if you tried to take it at home, you wouldn't have the password, so you can't take it at home. You have to go to the testing center to do that, because they have that password that they will type in for you. Especially this first practice test, shouldn't feel too stressful to you. It's just a progress check. They're going to send you topics you don't know, so don't panic if you don't know how to do something. I would try to do things. So if there's something you're like, I think I remember how to do this, I would try it, because it is an opportunity to pass off topics. So if you do something well on the test and that's coming up, ALEKS will remove that topic from your homework assignment, because you're already proficient at it. So I would just do your best on that, but I wouldn't stress out. It'll show you your score right as you finish, and I think usually always everybody's in the high 90s. So let me know if you have any problems or anything with that. And it is at the testing center, and you do have that 4-day window to get over there. All right, so section 1.6, more equations and applications. So we're going to work with absolute value equations, radical equations, and one more topic of rational equations. So the first ones that we're going to start with here are absolute value equations. So when you solve an absolute value equation, you first need to isolate the absolute value so that it's in this form where we have an absolute value equal to a number. So I'm going to flip to the first example so that you can see what we're talking about here is this extra stuff, like the 2 or like the plus 71 and the 5 there. We need to get that absolute value by itself first. Then we have 3 possible scenarios that occur. If this number right here is a positive number, if it's greater than 0, then we have 2 solutions, kind of like with quadratics. Either that stuff inside is equal to k, or maybe the stuff inside is equal to the opposite of k. So for example, just really simple equation, absolute value of x equals 4. Either x, the stuff inside, is 4, which would give us one solution, or it's also possible x might be negative 4, which would also give us, when we take the absolute value, 4. So this equation has 2 solutions. So that's the first possibility, if we have a positive number right here. Another possibility is that number is not positive, maybe it's 0. If the absolute value of u is equal to 0, then u has to be 0. So we just have one solution for an equation like that. And then our final possibility is maybe k is a negative number. If the absolute value of u is equal to a negative number, there's no solution because this is an absolute value. So it has to be positive. I mean, it could be 0, but it has to be 0 or a positive number. It can't be negative. So no solution in that case. So here's our first example, solving an absolute value. We have to isolate that absolute value. So we're going to divide both sides of our equation by 2. This 2 cancels out. So we get absolute 4x minus 2 is equal to 10. So this is a case where the absolute value is equal to a positive number. So we have 2 solutions. Either u is equal to k, the other solution is u is equal to negative k. So we have 2 possibilities. U is the stuff inside. So 4x minus 2 is equal to 10. And our other possibility, 4x minus 2, might equal negative 10. So to solve this first equation over here, I'm going to add 2 and then divide by 4. And I get x is equal to 3. For the second equation, I'm going to add 2. I get 4x is equal to negative 8. I still divide by 4, but this time I get negative 2. So I have 2 answers. I would just separate them with a comma in ALEKS like this, no parentheses. So that is if our absolute value is equal to a positive number. Here's an example where we're going to have a little different situation. So we still want to take care of the extra stuff first and get that absolute value by itself. I'm going to start by subtracting 71 from both sides of my equation. This would give us negative 65. I should check that because I'll have it wrong if I don't check it. Okay, it's right. All right, and then divide both sides of your equation by 5. We're still just working on getting that absolute value alone. And 65 divided by 5 is 13, so we have a negative 13. All right, so this is a situation where we have the absolute value is equal to a negative number. Well, that's not possible. An absolute value is always positive by definition. So this has no solution. because of this negative number right here. An absolute value cannot equal a negative number. Okay. Next topic. So we're switching to rational equations. We have one topic that involves rational equations, and then we'll switch to radicals. Now, this is a very challenging topic because we now have two different binomials in our denominator. I am going to solve this the way I think they teach it in Math 3 because I think that will be the easiest for the most people. So if you have a different way you like to solve it, then absolutely that is fine. There's more than one way to do it. But what I'm going to show you is to get all of the denominators to be the same. So I look, and this one right here has both an x plus 2 and an x plus 3. So we need to have that common denominator for all terms. That will be our least common denominator. So that term that comes first, the 3, it doesn't have any of those denominators present. So I'm going to times it by x plus 3 and x plus 2 on the top and bottom. So I haven't changed the quantity of that 3, I've just changed the form by multiplying it by this big fancy number 1. This middle term has the x plus 3, but it's missing the x plus 2. So we'll times it by an x plus 2 over x plus 2. Again, we're not changing the value there because this is the same as timesing by 1. On the other side of the equation, I would be extra careful with that negative right there. So I'm going to put it with the 1 on top just so I don't lose track of it. And it's totally fine to do that. Okay, so now I've created this equation where every single denominator is identical. And since the denominators are all identical, I can just focus on the numerators and use the numerators to create an equation. So 3 times x plus 3 times x plus 2 plus 1 times x plus 2 is just x plus 2, and that's equal to negative 1. So this first little part we need to multiply out. So I'm going to keep the 3 there for a second. This is x squared. I've got a 2x and a 3x for a total of 5x. And 3 times 2 is 6. And, while I'm doing this, I'm going to go ahead and add the 1 so that I have a 0 there. Make it a little bigger. Okay, so now I'm going to distribute that 3. So we've got 3x squared plus 15x plus 18 plus x plus 3 equals 0. So last combining up of terms, we get 3x squared plus 16x plus 21 equals 0. So we need to factor this. It's not a super easy one to factor, but we can do it. Leading term is a 3x squared, so we'll split that up as a 3x and an x. The most likely combo for 21 is 3 times 7. My gut tells me put the 7 here and the 3 here. So let's see if that'll work. That gives me a 7x. This gives me a 9x. So that does actually help us get 16, so it worked. And we need just positive symbols there for that, for that sign to work out. Okay, so we got it factored, and that gives us 2 solutions. So we have x is equal to, subtract the 7 and divide by 3, negative 7/3, and negative 3 would be the other one. Now, be extra careful here because anytime you're dealing with rationals, you've got to watch out for extraneous solutions. Our 2 excluded values are negative 2 and negative 3. Those cannot be our answers. So the negative 3 is extraneous, and we just have one solution, which is negative 7/3. Okay, so that's one example. I wanted to do that one more time because it is so tricky. One of the harder topics, I think. So we're going to try this one as well. Here we need a common denominator. You've got to make sure every denominator, the common demon, I guess, this time. You've got to make sure all of the different factors in the denominator are represented in your common denominator. So we need a y plus 1 and a y plus 2. I'm going to use that same strategy that I used last time. I hope that you remember it from Math 3. So, I just keep wanting to put an x there. Okay, so we've got this first term doesn't have any, it's a denominator of 1. So we need to multiply it by both of those factors. Multiplying it same top and bottom because that's just a big fancy number 1, not changing the quantity. I'm going to put the negative with the 2. I just make less errors if I do that. This already has a y plus 1, so we need to times it by y plus 2 over y plus 2 to get that common denominator. And on the other side of the equation, we already have a y plus 2, so we're going to multiply it by a y plus 1 over y plus 1. So we've got the same denominator for every term now. So we can focus on our numerators. 9 times y plus 1 times y plus 2. I'm going to go ahead and distribute that negative 2 right now. Minus 2y minus 4. And we'll go ahead and distribute the 4. So that will give us a 4y. Whoa. Try that again. 4y plus 4. Okay, we've got a little bit of multiplying out to do in this first spot. So we've got a y squared. Oops. We've got a 2y and a 1y for a total of 3y. And we've got a plus 2 at the end. And then we also need to distribute that 9 into those 3 terms. So this is a 9y squared plus 27y plus 18. I'm going to go ahead and subtract these. So I get my 0. So I've got negative 6y minus 8 equals 0. All right, combining up our terms, we have 9y squared plus 21y, because I combined this term with this term, and on the end we have a 10, an 18 minus an 8. Okay, so we get to factor this one, another one that looks fun. Now, sometimes when you factor with a coefficient, it's like a 9y and a y, but I think on this one, and it's good to remember that if it's a composite number like 9, it can actually end up being broken up as a 3 and 3. And looking at these numbers, I'm getting a 3 vibe from this. Just remember when you're factoring, especially if it's one that is hard for you to factor, just keep trying different combinations and you'll find the right combo. For 10, my most likely combo is 5 and 2. So let's see if that'll work. That's a 15y, this is a 6y, and those do add up to 21, so that worked. They both are positive again. So we've got our factorization to get our answers. And, if you need to write out solving these, go ahead and write them out, or otherwise you can just do them in your head. We would need to subtract the 5 and then divide by 3. So we get our first answer is negative 5/3. And then our second answer, subtract the 2 and divide by 3, is negative 2/3. And in this case, our extraneous values, our errors, would happen at -1 and -2. So both of our answers are fine in this case. And we would just type those both into ALEKS separated with a comma. Okay, that is the last rational equation. So we're going to switch to radical equations, which you should have worked on solving last year. When you're solving radical equations, it's kind of similar to those absolute value ones. The first thing you want to do is isolate the root. And then we do want to check our answers and watch out for extraneous or imposter solutions. So in this first equation, we'll start by subtracting 1. So I have the square root of 3y minus 12 is equal to 3. Then we can square both sides to undo that root. So we'll do a power 2 on both sides. The root and the power of 2 sort of undo each other. So this side just is now a 3y minus 12, and it's equal to a 9. So now we're just solving for y, simple linear situation now. So 3y is equal to 21, and y equals 7. Now, sometimes when I say you should check your answers, people don't either know how to do it or they don't know why they should bother. But roots do sometimes have imposter solutions. So what I would do is use this side of the equation and substitute the y in your calculator. So in your calculator, you would type in 3 times 7 minus 12 under that root and then add 1. And you're just testing to see, does that give me 4? And the calculator in this case does give you 4, so that's true, and the answer works. So we checked it and it was fine. On this next one, I'm going to show you that sometimes it is not a solution. So again, we'll go through kind of the same steps here. We want to get that radical by itself. So we have the square root of 4y minus 20 is equal to negative 2. We square both sides to get 4y minus 20 is equal to 4. We can add 20 to both sides to get 4y is equal to 24. And we can divide by 4 to get the apparent solution 6. So it's acting just like it's an answer. So we're going to substitute 6 into that original equation and see if it equals 1. So the square root of 4 times 6 minus 20 plus 3. So it's that entire side of the equation, and we want to know, is that equal to 1? But if you type that into your calculator, this actually gives you, I believe, 5, not 1. So it's not true, which means this is not a solution. And in this case, there is no solution to this equation. Sometimes you'll just have one extraneous answer and the other one works, but if your only apparent solution ends up not being a true solution, you would just indicate that there's no solution. Okay. Solving radical equations when there are two radicals. People see these and sometimes they look harder, but they're actually easier. So we start with squaring both sides. And when you square both sides, you end up with the equation 8w plus 1 is equal to 4w plus 9. And that is a pretty simple equation to solve. So I'm going to get my w's together and get my constants on the other side. So we have 4w equals 8, and we divide to get w equals 2. Again, it's a good idea to check your answer, and you can probably check this one pretty simply just in your head. If we sub in a 2 there, we end up with the square root of 17 equals the square root of 17, so it works. Okay, this is the last topic, but we are going to do 2 examples of it because it is difficult. So we talked about with radical equations that you want to get the radical by itself to start with. Well, this does start with the radical by itself right here. So we are ready to square both sides. But when we square that left side, we need to remember that powers like squaring don't distribute. An x plus 1 squared means that an x plus 1 is getting multiplied by another x plus 1. So that's x squared plus 1x plus another x for 2x total and plus 1 on the end. So we end up with x squared plus 2x plus 1 is equal to 28 minus 4x. This is a quadratic equation because it has that x squared term. So we want to get all of those terms over to one side so that we can try to hopefully factor to get our answers. And I don't think you'll have to use the quadratic formula on these. I think they will be factorable. So we've got x squared plus 6x minus 27 is equal to 0. So factoring, our factors are going to start with x. For 27, that's 9 times 3. We need a middle term with a positive 6. So it's an x plus 9 times an x minus 3. You need to check your answers. It's a little trickier to check your answers when your equation has an x on both sides of it. We're going to check negative 9 first, and then we'll check the other answer, which was 3. So for negative 9 to check it, we would think about the original equation. Negative 9 plus 1 equals the square root of 28 minus 4 times negative 9. Well, on this side of the equation, we have negative 8. And on the other side, we have the square root of 64. Well, if I type in square root of 64 in my calculator, I don't get negative 8, I get positive 8. So that 9 is not a true solution. Let's check the 3. 3 plus 1 equals, and I'm just subbing it into the original equation, 28 times 4 minus 4 times 3. So we get 4 is equal to the square root of 16. That's true. So we can say that that is the true solution, and we would type in the answer 3. You do want to check your answers, and don't just assume if there's a negative number that one's extraneous and the positive one works. Sometimes it's the opposite. All right, we're going to do one last equation. This is the last one. So again, that root is by itself ready to go. We're going to square both sides. So we get 5x minus 16 is equal to x minus 2 squared gives us x squared minus 2x for a total of minus 4x and plus 4. This is a quadratic equation, so I'm going to get all my terms over to the same side so that I have an equation that's equal to 0. So I have 0 equals x squared minus 9x plus 20. Let's see, so we're thinking about factors of 20. I think 4 and 5 are going to work. We need them to both be negative to get that middle term of negative 9. So that gives us two solutions, x equals 4 and x equals 5. You should check these, especially on tests. You can type them in your calculator to check. You don't have to write them out on your paper, but it's good to check. So checking the 4, 5 times 4 is 20, minus 16 is 4, the square root of 4 is 2, and then 4 minus 2 is 2. So that one works fine. Now I'm going to sub in the 5 and double check that one. 5 times 5 minus 16 equals 5 minus 2, maybe. So this would be the square root of 9, which is 3, and the other side is also 3, so that one worked. So this is an example of where both of the answers are fine and you do have two solutions. So you may not have an extraneous one. Just be on the lookout for those. They are a commonly missed problem when they're extraneous. All right, so if you're having any problems or if you have any questions, you can email me and I'll try to get back to you as soon as I can. Thanks so much.